Okay, now look at this one. Stretched by length x naught, and the spring is stretched by x naught. So when I stretch it, so this is okay. I should go for till here. No? This is, so what is the elongation of spring? No, x1 plus x2 is the elongation of the spring. Now how much of spring force will act? Kx will act, not kx1. Very important. This end is displaced by x1, this end is displaced by x2. So what is the total elongation of spring? X. What is x? X is the elongation. So sorry, this x naught is elongation. So now don't write kx1, kx2. No, not like that. Kx only should be that. So now this force, what it will do? These are released from rest. So again, when the springs come to the original position, when the blocks come to the original position, what spring force? Spring force, in fact, did work. No, spring force did work. So when the force acts, the body will accelerate. Due to acceleration, speed will increase. Due to increase in speed, increase in kinetic energy. So now these will have velocity v1 and v2. We have to calculate that v1 and v2. Therefore the question, find the speed of the blocks when spring is relaxed. So again, what is the state of spring? How to calculate that v1, v2? Who is the force doing work? Spring force only. Can we apply conservation of mechanical energy? Yes, it is. Then what is the net force on system along x-axis? 0. So initial momentum equal to final momentum 0. So m1 v1 minus m2 v2. Then kx naught square or kx square should be equal to m1 v1 square. So mechanical energy is conserved. So what is this? What I am writing is conservation of mechanical energy. So previous problem you didn't apply, now you are applying it. Because what is this spring force? Conservative force, no? If we are able to apply. If there is any kinetic friction acts, you cannot apply this, but you can apply. If the friction acting on both the blocks is kinetic and equal, this friction equal to this, you can apply this, no problem, but you cannot apply this one. So momentum is not bothered about nature of force. Momentum is all about net external force, 0 or non-zero. In the direction in which it is 0, in that direction you can apply it. This is what a student has to make observation here. V1, V2 or two unknown things, solving will get the required answer. Now what will happen to center of mass of system here? Suppose m1 greater than m2. We'll put it. Center of mass will lie near to the heavier mass. Anything will happen to center of mass. So center of mass will be there only. This is the most important thing student has to make observation. So where the center of mass will not shift. You can see the vertical line. Okay, are you getting? So center of mass. Why it will not shift? Net force along x-axis 0. The blocks will be oscillating, but center of mass will not move. There's unlimited problem. This is the best topic I'm telling you. You have to work out numerical, different. That too diagram based, not some math based things. Please avoid